Whoa. I wonder. My better screen share. Let's see. Okay. Screen share. See, so I think what we want to do. Why is it not responding? Okay. So I think I wonder if we can. But I think I'm on it already. Okay. Let's see. Let's see. Let's see. Let's see. Invite people. Try this link. Okay. Let me go to setting microphone. Okay. Okay. Yes, I'm gonna do most of this. I'm just gonna iconify this. Okay. Wait, one. Okay. All right. Let's see. Okay. Really? H12 client. Okay. Okay. Let's see. Oh, I think I see that I have a viewer, which must be Charles. So you probably are hearing me. Maybe there's a way where you're viewing and not participating. You should be able to join the Hangout. Let me see if this is the same. Yeah. So you can probably hear me, but I don't. You may be joining as a viewer, not a participant. Let's see. I thought. I'll send you an email. I'm asking you, since you're not showing up as a participant, just as a viewer, I can't hear you. So I'm asking if you clicked on the link below. I'll copy and paste this in the chat window, or if you clicked on the link of the event. I'm just sending this email. Also, you have I can. Okay, I see a Google Plus note. Let's see. Let's see. So it should be cameraman. As guest join, Brooke. Yeah, if you join, you should be let's see. Yeah, getting your comments is really critical. So let me, I didn't have this problem before when we did this hangout a while back. Let's see. Yeah, I see one viewer. That's got to be you. Let's see. Actually, I see you sent me another email. Okay. Oh. Oh. Okay. Okay. Let's see. I'll just kind of wait until I think when you join as a participant, you'll show up as a. Okay. Okay. You can also call in. Let's see. Okay, I see a viewer. This is probably Charles. I see a viewer just happened. Oh, now it went away. Let's see. All right. Let's see. Oh, wonder if I can make the hangout longer. Broadcast a large video IC to the audience and hide the other video feeds. Okay. Camera off. Okay, I think I see that you're a viewer. Again, I don't see. When you join, there should be another. I think you see this screen. here where there's one, you would show up here next to me. Let me give you my phone number in case. Okay. Okay. Looks like I'm still. Okay. Okay. Well, actually, yeah. Let me call you.
Hey.
Hey.
Miraculous.
Yeah, technology does work sometimes.
Hi. Thanks so much for your patience. I appreciate it.
Thanks for going through the trouble of installing everything. I know
not at all. Not at all. Okay. So tell me what's going on. What's happening?
Okay. So, and just so you know, what I'm going to do is I'm going to start. Well, actually, we're being recorded now. So, and again, I'll edit this out, or any of the previous stuff out.
Sure.
So, yeah. So what I'll do is I just wanted to give you an opportunity to. I can maybe spend 10 or 15 minutes just kind of showing you stuff, and then if you have any questions while I'm showing you, I'll screen share my worldwide telescope running locally on my machine, so you can kind of see it. And then if you have questions, stop me. What I'm gonna do is I'm gonna turn off the video where, like right now, when you say something, say something.
Yeah. Hello.
Yeah. So now the video goes to you when you talk. I'm gonna stop that. So we'll hear you, but the video will basically be me screen sharing worldwide telescope. So,
Perfect. The goal is to create a 10 or 15-minute continuous tutorial where you're showing the functionalities for everyone to see, right?
Exactly. So then when this is done, I'll share this with the rest of the council. But definitely, this is meant to be a little bit of a conversation. So if there's something you want to know more about, definitely ask it, because I think that inquiry from you as a novice or somebody who doesn't know as much about it, and me as an expert, is helpful for the other people who are probably going to be in the novice, see themselves in the novice category.
Okay. Now, have put up the HTML5 or the client up now. Does my screen show up when you are talking at all?
You'd have to share your screen. What I'll do is, why don't I start with desktop client, which you won't be able to see. That's why it's helpful for you to see when I screen share it, because otherwise you don't really have a sense of what it does. And then we can talk about, so we'll probably talk about the desktop client first, because that's something unless you see it, you don't know what it does. And this is the only way to see that. And then we'll talk about the pieces. So that'll be kind of the reference. And then we'll talk about what the HTML5 client does currently. And in that case, I can probably, either of us can share each other's screens when it gets to that point. But you have to go on the left-hand side of the thing. There's a screen share, like it's the green. I don't know if you see it. It's the green. So when you screen share your screen, so I'll start that now. Let me screen share my. You basically point to. So now you should see worldwide telescope.
I am still seeing you. Oh, it's switching. Now it's worldwide telescope. Good.
Okay. So when you want to take control, I'll give you that. So for right now, I think. Are you going? By the way, are you going back? Let me actually mute you. Not mute you, but I'll make sure that you don't take over
the screen as I talk.
Right? The screen, yeah. Mm-hmm. So let's see. Hide from broadcast. Okay, so I think now you're not.
Right.
You're not
my little mini screen just went kind of darkish. So
okay, good. So I think that now we're kind of stuck on my screen share, which is where we want to be.
Great.
So it's capturing our audio and then the screen share. So this is so I'll kind of start here. We'll probably edit it from here on. So all that stuff will be kind of prep stuff.
All right.
So now we'll kind of. So the purpose of this is to spend a few minutes demonstrating the functionality of Worldwide Telescope, and then also throughout this, definitely ask questions if you want to learn more. We can both hear each other, so just speak like we're having a conversation.
Sounds good.
And so Worldwide Telescope is a bunch of stuff behind the scenes, which is servers and tools to convert data, and then the data themselves. And then we're going to be talking about a couple, the two most powerful front ends. And the most powerful and most mature is this desktop client that currently runs under Windows. But that's possible. I mean, this is all possibilities for future development to change that. But the Windows application has these different modes. One mode is looking at when you first start it up. I think it starts with Solar System, and just to show you what that does, this is a 3D representation of our solar system. And solar system, by the way, means the entire universe. It just means it started with just a solar system. So in terms of having planetary images of planetary surfaces on top of bodies, or at the right shape and the right location in the sky. In a solar system view, one of the cool things you can do is you can actually look at it face on.
Oh, nice.
Then you can this is actually you see up here, and this may not be. You may have to make your screen full size to see this, but basically there's a time controller here where I can advance things day by day, and when I apply it, it should actually the easiest thing is actually to speed up time. So if you see the planet orbits moving slowly.
Yeah.
Okay, I can make them move more rapidly. So this is if I stop at any time. So if you wanted to see this is a way to teach things like I've taught some classes at Northwestern where I talk about why space missions to Mars are sent every couple years during opposition when the two planets are close together, and you can easily kind of advance time to that location, that time, see that they're close together, see that in a year past they're very far apart, and then in 2 years they're back to being close together. And so that can be done with real times. You can go back to any time in the past to see where the planet's configurations were, stuff like that. The other cool thing in this mode is that we actually have the asteroid orbits as well. So so you see here, actually, these are not just the planets moving, but the asteroids themselves. So you see and they're broken up into different zones. Right now I'm zooming in on the sun. So you'll see the yellow here are the Trojan asteroids. Mm-hmm. And they're moving pretty fast. So let me kind of slow them down a little bit. And then the kind of magenta going from light to dark magenta, or the main asteroid belt. And then you see there are some asteroids. And now I'm maybe a little bit confusing because there's a lot of stuff happening here. This is probably too busy. Let me pull back a little bit. But there's some data. So we have orbital elements for from all the asteroids in the main asteroid belt that we are representing here, as well as the Trojans. When you get further out in the Oort cloud and the Kuiper belt, there's a statistical representation of what we think that is. And these are things that can always be. I think this is actually one of the things that the AAS can bring to this tool, which is better representation of data. Some of these things require simulations to populate their statistical orbital properties. Some of them are, again, things that are detected. We can actually pull those in and visualize directly. But things like the Oort cloud and Kuiper belt, as we're learning more and more about them, we need to kind of get those data in here. So that's one aspect of the solar system. I'll kind of pause time again. I'm going to turn off the constellation grid because it kind of gets confusing to see so many things superimposed in the sky. I'm also going to turn off the asteroids. In the solar system mode, all these things, you see these things along the bottom screen, all the planets. If I click on a planet, it'll take me there. So this is going to take me to Earth. Now, of course, the data, the different planetary bodies are represented with the data we have available to us. So the Earth, because of all the remote sensing on the Earth, we have a lot of data on the Earth. And so things like, I can go to New Zealand and like zoom in on mountains. And by the way, all the data here are being pulled in real time. If you're doing tours, there's a way to cache the data before you run it. But since we're doing it live, some of the representations will be built up as data gets pulled across the network to be viewed. So now I'm zooming to New Zealand, here a mountain range, and I'm not very familiar. I've never been to New Zealand, so I'm not sure what mountain range it is. But as you see it, I can get closer to it, and the levels of detail kind of get added. And so this is the same way that Google Maps and Bing Maps and all the different mapping services work. And so this is the Earth. I can also I don't have it set up, but I can set a reference point here. So one of the things I can do is I'll just kind of show you how to do this. On the Earth, I can say new reference frame, and I'm just going to call this New Zealand. Next, this is telling me the size of it in meters, and I'll put the altitude a little bit higher, like 1,000 meters, a kilometer in the sky, or off the surface of the Earth. Now, if I track this reference frame, I actually need to change the altitude. That's why I'm not seeing it.
Okay.
So make it 2,000 meters. It's from the average distance in the Earth. So let me.
Are you seeing an Earth right now? I'm seeing a star background.
Oh yeah, that's because oh, I see the problem. Actually, that's a mistake. Let me delete this. Sorry, let me go back to the Earth again.
No problem. And you must be clicking various buttons or tabs off the screen that I'm seeing, I think, because what I'm seeing right now is just the sort of 16:9 vision right now, like of the Earth with Antarctica on the right side.
Oh.
And then a part of the Earth underneath is like cut off.
Oh, so you don't see the buttons on the bottom or the side?
No, right now I don't.
Okay. Let me see if I can share. Just use a window to pull across the whole screen. Hold on. Let me see if it may be just sending out the context of the frame showing the visualization and not the tools, because the tools are kind of useful for you to see. So let me try to turn that on. Let me go back to Google Hangout. Go share screen.
I'm back to you now.
Okay. Yeah. So when I do this, there's gonna be a weird kind of tunnel vision effect. So don't freak out.
Let me ask you this. Your goal is to have this video about 15 minutes long. Is that right?
Yeah. I'll edit some of this stuff out. So right. Don't worry so much about making it.
I have somebody else trying to call me, who's going to be calling me at 2 o'clock. So it's 1:45. I didn't want to over mess you up. I'm sorry about all the timing and so forth. That's now fine. I do see the tabs at the bottom and on the side.
Okay. So, for instance, what I was going to show you, if we have 15 minutes, I probably won't go into this. But basically, I can make a reference frame anywhere on the Earth and then show the entire model solar system from that location. So, if I pan up, I'll see the sky from that location. So that would be a way to, for instance, if you're doing I've done a class at Northwestern where I said, what's the view of the night sky from the Technological Institute on campus, and I can put myself exactly at that location and see, for instance, where next to another building the sun sets or whatever at a certain time. So you can make very accurate visualizations of what the sky would look like from a location. And this can be done for observational preparation for amateurs or students or stuff like that as well. Mm-hmm. The other thing, so this is the solar system mode. The other mode is the sky mode. And in the sky mode, and this is a thing that is probably of great interest, for the journals and things like that, where I can click on any object. So for instance, here, everything along the bottom is called a context menu. As I mouse over different objects, you're seeing a circle in the main view, right?
Yes.
So and now in the objects in the lower, these are kind of these are objects that are in the field of view. If there's a little kind of icon with a picture on the upper right, that means there's a separate image that's a pointed observation that's available of that thing. So for instance, here's one called, the titles of these come from various locations. Sometimes there are various sources. Sometimes they're the data set itself or the source name. This is a public press release image. So the title of the press release is a dying star shrouded by a blanket of hailstones from the Bug Nebula NGC 3602 or 6302. When I click on it, it'll take me to that location. And so if I zoom in, you see this zoomed in image of this is probably Hubble on top of the background at much higher resolution. You see that the zoom in, okay. And then when I crossfade between them, I crossfade out the overlaid high resolution image on top of the lower resolution background. And you see there's a pretty good registration of that. So as I pull out, I see more and more objects populating this context menu because my field of view is getting wider, and the database that is the Worldwide Telescope has access to will have more objects in it. So if I stop here, you'll see that now they're populated with, looks like there are a couple of planets in my view. There's a Cloud cluster. There's a few galaxies and NGC cataloged objects, and there are actually 18 pages of these different objects. So you can kind of peruse through them. So and this is kind of in the exploration mode of Worldwide Telescope. Then there's also this, and the exploration mode can go through all these things. It can be the solar system mode. It can be the sky mode. And then there's also a thing of guided tours. And these are tours that either are served to the user via the interface, or I can create my own and save them locally as files. So if I were teaching a class on, like I did at Northwestern on the solar system, and I had a class on Mars, I could go explore, open, tour, and now I'm going to be opening a tour that I created. So I'm going to go over to documents, Worldwide Telescope, tours, and so for instance, here's a tour of actually this is a cool tour. This tour shows came from a class at Columbia College in Chicago, where they had students peruse through high-rise imagery from Mars, which is on Mars Reconnaissance Orbiter, and the students found this one hole in the image, which it's a cave collapse probably that we're zooming into, and the high-rise team hadn't even seen it. So the professor Jim Schweitzer at Columbia got in touch with them, and they had some correspondence between the students, the professor, and then the people in high rise to confirm that this was a new discovery. And so students put this tour together, and all it was simply highlighting this one object. And the students could have added narration to it to say what they're seeing and things like that. But this is a good example of data sharing, where they found something they thought was cool, and it can be shared with somebody where somebody else can actually go in and look at it not like as a video or a screen share, but as an interactive. This tour is an interactive, object that I can play around with. So that's a cool way to share information. And this is a good example of, now this data set actually has high rise, which are the strips. That's this narrow black and white strip on top of the color image. So the color comes from one global mosaic, and then the high-rise strips they're taken as it's on MRO is on a orbital polar orbit. So these are all strips along basically north-south strips that you kind of see overlaid on top of the background image. But that's an example of a tour created to explain an object or a discovery or something. So we have a couple minutes. I was going to say, do you have any particular questions of me, and I can answer them as far as either creating things or
Well,
exploring?
yes. The functionality is great, and it reminds me a lot of Starry Night Pro, which of course I get advertisements for in my email all the time. Hey,
Right.
use this for a tool. And obviously, Worldwide Telescope is far more than that. So I'm curious to know a couple of things in that regard. As far as this and Starry Night Pro, how do you transcend it? And then let's say we wanted to use that cool registration tool that you used in crossfading for actual, say, student research type projects, similar to the one that Jim did with his students here on Mars. Can they do that in sky mode where they're looking beyond out into the universe and things like that at a galaxy or a star cluster or something like that?
Yeah, exactly. So first the question was, how is it compared to Starry Night Pro or some of those other tools? In general, I think the tools like Starry Night, and actually there's a similar aspect, which is the planetarium tools that run professional planetariums, have a similar 3D solar system view like this. The one difference, a couple differences. One is it's number one, it's free. So all those planetarium tools, and although Starry Night does have some educational and different organizations can get discounts or site licenses, things like that. Worldwide Telescope is completely free. So the nice thing about that is that if you want to have your students do a project, there's no, you just point them to a website. Then as long as they have now the Windows installer is the one thing that right now the full functionality requires Windows. You can do quite a bit. And this is probably one of the things we could do with the web client as well. But some of the more complicated things need the graphics performance of the desktop client. But we're close. The team is close to adding WebGL, which is a way to get to the graphics hardware to enable a very beautiful rendering. For instance, if I go back to the solar system mode and look at Mars as a planet. Let me turn off the overlay. I can put grids on it, which is nice to know where you're at. That's actually pretty important when you're trying to find locations. I get this all the time when I look up a paper and I try to find lat long coordinates.
Yeah.
But if I zoom into this and then put this up at an angle, you see there's a nice atmosphere. And again, there's coordinates to help me give me a context. All of these sort of things are really kind of best in class visualization in terms of lighting, atmospheric models, all this. So it's kind of as good as Starry Night in most of those cases. And then the sky mode is actually quite powerful, and the ability to your students, for instance, could take an amateur telescope, and there's a way to connect through an ASCOM interface, a telescope through a wide telescope. I don't have one connected to this my home computer, but if I had one, I could connect to the telescope, take a picture. It would plop it up in the sky in the right location. So that all that crossfading that you could do here could be done in a tour to either the students could do a research project, a lab, and then they would create a tour to represent their understanding of that topic. And that can be shared and worked on as a group, for instance, and they can build up this presentation. And it can have narration, extra data can be pulled in. In the sky mode, for instance, I can take I can open an image, and again I can open a FITS file, and it would plop it up in the right location. I basically say open astronomical image, and I go let's see, data. Actually, is it assets? I think it's called assets, images. So if I click on this image, it's a TIFF image that has these things called astrophysical metadata, visual metadata standard embedded in the header of the TIFF image. And so this image is actually a TIFF that's overlaid on top of the night sky, on top of the DSS background. You see I'm crossfading between them. And so this TIFF that I'm looking at, and the registration isn't actually, it's pretty good between the two, but that it's actually overlaying that on top of the DSS background, and places like various Hubble PR and data sources, Spitzer, different observatories either make their raw images or their press release images, embed them with these tags. So if you had one on your desktop, you could actually very easily view this. And this is actually one of the things that it's exactly the same performance and interaction mode in the web client as the desktop client. So that's a nice way to share this kind of layered view of the sky, showing either different wavelengths or bands or filters, and how different objects look, the similar or different between them.
Great. So for example, if I really like this galaxy and I want my students to look at this object in the infrared and then the ultraviolet, there's a tab that I can sort of click and say, show me the Spitzer image, or show me the IUE spectrum, I guess, or the image from some other mission or something like that, like Galax or something like that. These sorts of things are all available.
Yeah, so there are two ways to it. One is the background. You can say, look, like right now I can I have this pointed image, and I can, instead of right now it's on top of the DSS background, I'll turn that back on. I'm going to turn the background now to be a WISE infrared image. Now some of these things are going to be very different spatial scales. So you see and I'm not sure what the origin of this image is, but it's obviously much higher resolution than the WISE background. Let me try a 2-mass. Okay, this is a little bit. Okay, so this is a good example. So this is 2-mass in the background and this pointed visual image in the foreground. And so I can make that change, or I can go over here to explore, and then go up a level, and then I can look through different surveys. So I can say, what does Spitzer see? How do things look different by looking at catalogs of images from different missions? So this is infrared, for instance, and I can do those overlays. So if I click on this is Andromeda in the infrared from a Spitzer, it's going to overlay that as an overlaid image on top of right now, because I have the 2-mass background, 2-mass. And then when I get to it, I can then crossfade between them, or between Spitzer and 2-mass. And then I say, well, maybe I want to look at that with digitized sky survey as a background, and now I'm looking at Spitzer compared to visual to infrared. So you can stack pointed images, or you can crossfade between two different all skies.
Nice, very nice.
And again, the mode is in this kind of free exploration mode, as well as this narrative mode where you're trying to communicate something. So we've used this to create pretty sophisticated video abstracts, which complement scientific articles, to kind of taking you through the highlights of the paper represented visually with the real data that was used for the paper, as well as things for the public. You can render out. There's a way, once you have a tour, there's a way to render to video, and then this will save the tour in a sequence of frames that then can be added together for a video. So there are various ways to reuse the work that you've done in making in bringing the data together for on a topic, and again, make it informative. The video, something that is used in the web client or the desktop client.
Wonderful. Now, I guess it would be too much to ask the program to provide me with some photometry too, huh?
Yeah, no, that's one of the things. I mean, right now the program doesn't do that. There's a conversion stage that converts the FITS files and the quantitative information into a color image, and that color mapping is done, and we lose the data values behind it. It's not. The team has considered making links so that the original FITS file has references to its like the pixel in that FITS file to extract a quantitative number from it and be able to do more analysis. But right now, that's not the way that Worldwide Telescope works, because it works on the images. There are ways to extract coordinate information based upon what you're looking at within Worldwide Telescope, and then there's an interface called SAMP, which is the one versus TopCat. I don't know if you're familiar with TopCat, but it's a tool out of CDS that
yes.
CDS that does that actually has an interface to for it to like pull in data, and then you're driving Topcat to pull in data from different sources based upon a position on the sky. So in that, one of those sources could be a FITS file or some photometric catalog. So it's kind of connected to other tools that bring in the quantitative information, and then use Worldwide Telescope as the visual interface to explore, and then it pulls in the numbers from some other data set.
Great, thanks.
So
well, I think this is just a terrific tool to be able to zip around the sky, showing the pictures, and then if you, depending on how you structure your class or the levels that you structure your class with, you start with a lower level and then they zoom and they play with images and learn from that. And then from there go on, if they want, to places like Topcat or to NED or to other places, and pull up the more sophisticated work if they're actually doing some sort of in-class research, because that's exactly the sort of, yeah.
And there's one last thing just on that point of research, where if I go to Explore, I can say Show Finder, and there's a Finder scope. And then when if I say research, this allows me to exactly do what you just said. I can look up Andromeda on NED, and then it will get that information. And it does do a source just by source name. So actually the name of this image is the Three Faces of Andromeda, which isn't quite as isn't resolved in NED, but they're basically.
Thank you so much. Okay. Bye-bye.
Okay, thanks. Bye.
No, I'm still here.
Oh,
I'm back.
You're back. Okay.
I put the other person off for 20 minutes.
Oh, 20 minutes. Okay.
Yeah, go ahead and give me like 5 or 10 more. I think we have plenty of time for that.
Okay. So in this case, for instance, if I go to let's say this is a good example. If I go to like M31, if I click on this, it takes me there, and then I show the Finder, and then I say research information, look up on ADS, for instance. It's going to take the name M31, send it as a query to ADS, and now I'm getting all the papers that are published as if I had in a separate browser just typed in M31, but I'm able to do this all within my visual interface to see the context to where I'm at. And so this is a great way for students that, where you have this visual portal into data that doesn't just end with the with the images that are in Worldwide Telescope. It actually has ways to query external data sets and sources like ADS and NED and SIMBAD that are curated totally outside of Worldwide Telescope. And without having to learn a whole nother, we're all very familiar with ADS, but as a student, this is kind of a good way to get connect research, real research, to be able to get the full proposal. And actually, this is probably going to fail because I'm not on my VPN. Okay, so there actually is a way to get that the abstract from within Worldwide Telescope.
Great, wonderful.
Yeah. So, and like I said, I've used this with my students where I would give tours that would be in front of different classes on different topics. So, one example is I'll just take one example. This is a Mars surface. This is a Mars overview, which I use to kind of introduce my class to Mars. And so I'm just going to kind of go forward through a couple. And so this is a way where before a class, if I'm going to talk about different surface features like Olympus Mons and Valles Marineris on Mars, I can give this kind of global view of things all within the tool. The students, kind of see it almost like a video because I'm playing it back as a video. It's kind of a context thing. So now I'm going to go over. Now I'm kind of fast forwarding through these slides just for the sake of time. But I'm right now talking about the South Pole, and then stepping through different locations, and then so I kind of gave this as an introduction before at the beginning of my lecture, And then as I got into the lecture, I would go into more details about how the crater counts vary between the northern and southern hemispheres, and and I prepared a nice camera path that kind of does all this, but it's interactive. It's not a video. I can actually I can pause. I can go over here and pause it and explore it on my own. So, and I had my students most of the time that one of their questions or one of their comments was, or most of them actually did go and look at the tours that I had that we put into our content, our kind of classroom content management system, where they reviewed the tours as a part of their preparation for exams and stuff like that, where it wasn't just looking at a video or some PowerPoint slides that I put on Blackboard. It actually was a tour that they could interact with and explore on their own. And that was a pretty powerful technique to give them that's well suited with the type of exploration that students want to do, where they want to be more interactive and hands-on when they look at stuff like this.
Yes, very much so. This is great.
Yeah. So, and then the other thing that we were able to do was actually create tours, have the students create tours. So, it's like in 2 minutes, I'll make a really short tour, just to kind of give you a sense of how easy it is to do. So if I say create new tour, I just say I'll say Mars. I say add new slide. This is a starting position, and let's say I'm gonna just come out to this view and say set in camera position, and then if I push play, I've now created a one slide tour that just does this little thing. You can imagine then just stringing together one slide to another to do the kind of storytelling, either you as a presenter, as a lecturer, or if you're having your students represent that they know some understanding about an object, or they investigated Mars or volcanoes or whatever the topic you're having them do. It's very easy for them to create content. So that's another thing that's compared to, I think, most of the other software systems that do this kind of 3D stuff. A lot of work has been done to make this very similar to PowerPoint and doable without a lot of technical background from kind of production experience. So that was one of the things that worked out pretty well in a classroom experience, where they could work on a tour again that represented their understanding about a topic or a phenomenon.
Very nice. Great. Thank you very much. It looks really interesting. Is there any other particular item or thing that I can answer for you? Any questions?
Yeah. Well, I guess, do you have anything about where, in the educational arena, where what things that you think this maps to, or anything missing out of this you think that would be necessary for this to be really useful in the sort of education that happens with WS members?
It already shows all the important things that I was looking for in terms of the ability to display interesting things, to teach using time lapse and so forth, as you did with the solar system demonstration, and also the ability to link out to genuine, or what we might call genuine research, by using this as a starting point. You can create educational environments for the students as projects and so forth, which is great. I think I often, for example, assign my introductory students Galaxy Zoo or other Zooniverse projects to do. I'm trying to think whether or not there would be an interface someday between citizen science activity and this, whether this is a different kind of tool than that, because those are very focused individual projects and so on. But I think this is a great start to the introduction for me anyway, as a novice, in terms of just the kind of capability that's possible for WWT. So thank you very much.
Okay, well, thanks. I appreciate the time to look at this over. If you have any more questions, let me know, and otherwise I'll see you in Florida.
Okay, terrific. Thanks.
Okay, bye.
Well, that's the end of the thing. So
yeah, I'll send you a link when it's all edited this afternoon.
Good. You have enough information for the tutorial you wanted to give?
Yeah, I think so. I'll try to condense it down, because I want to make it short enough that people actually watch it. I don't want to tell them they have to watch an hour thing, which they wouldn't be an hour even if they did it. But I want it to be. I'll cut out some of that, all the beginning stuff, and try to keep it as short as possible so people can get a chance to see it. But
yeah, I think if you're willing to put in the time and effort, I know it's a pain to edit video, but if it were down to sort of the 10 to 15 minute zone of all the best stuff, I think you really have given a good picture for us novices on what the possible capabilities are. And the point that it's free to the end user and it has as much as you would otherwise pay for in commercial packages and so forth, but it allows also this sort of federated platform from which you can do all kinds of things that you want. I think that's a real plus.
Yeah, that's definitely the plan. So I'll be working on that this afternoon, and I'll send you a link. And if you have any comments on anything that you think that was either missing, I'd be happy. And I can always re-edit it. This is actually pretty. I'll get all the assets together, but I think keeping it short is important because I think everybody wants to, everybody's time is pretty short between now and the meeting, and I'd rather have more people look at it than having some really long video that went really deep, but that nobody looked at. So.
Sounds good. Yeah. Well, your time is precious too, so I know how hard it is.
Yeah.
If you want to put an hour worth of video on YouTube, it takes 2 hours. But if you want to put 10 minutes on, it takes 10 hours, right?
Exactly. That's exactly what's going to happen. So, well, I have 10 hours, but I don't have much more than that. But
all right. Thank you so much. Really appreciated that. We'll see you.
Okay. Thanks, Charles. See you later. Okay. Bye.